So I got about 30 slides with a lot of pictures. So, and that's what I titled it. I don't know why I titled it that. What do we really know? So, if you follow the news, you know there's a debate about climate. There is no debate about climate. That's a made-up debate. The scientific community is 99.9% unanimous. We know what's going on. We understand the climate system. I think, when we think about what science is, by the way, I like cartoons, so I use a lot of cartoons. And, what Prof and I do as scientists, probably there's other scientists in the room, but this thing called peer review. It is really, really fundamental part of what we do. We discover something, we think we have something new, but we can't just publish it on a website and say, oh, that's the end. We have to submit our result to a journal, and it goes through this process. And I like this cartoon, that's kind of what it's like. It's pretty accurate, actually, because other scientists are trying to knock our idea down. And it's only if we get through there, you see at the end it says paper accepted, that the idea is acceptable. Now, it's not a perfect system, but it's better than anything else. It's better than just publishing anything you want on a website. So this is a really, really important part of science. And you think about what science has done for us. I mean, whether it's our smartphones or lasers or medicine, weather forecasting, you name it. These things would not have been possible without science. And every one of these inventions or activities that humans have done started with some scientist in a lab, like a laser, for instance, which is so fundamental to so many things. Somebody in physics discovered that if you excite, these atoms, you could get light, and if you focus them, you could do it. And they had to submit their paper to peer review, and it survived. Now, so this has really been a very, very important process for humanity's progress. And now we have people saying, oh, I'm going to like this idea of science, but I don't like that idea because I won't make money off of this one, or it's going to cost me money. And that's what we've seen time and again. And the whole thing about climate denial is it's not new. We've seen this many, many times, and I'll show some examples. I have two organizations on there because they got me thinking about this Thanks Science. One is the American Geophysical Union, one is the Union of Concerned Scientists, two really good organizations that I'm a member of and send money to, and they both had this idea of thank scientists, because in this era we have this science denial. People don't want to believe vaccines, or don't want to believe, what next? We're going to not believe in gravity? It's kind of like, where does this go? So we really have to remember what science has done for us. Major controversies. So I said climate denial is not the first one. Actually, it goes back to the 16th century. Copernicus said that the universe, our solar system, revolved around the sun, not the earth. And they nearly killed him for that idea because it didn't go along with the current religious doctrine. Well, eventually people started figuring out with their own telescopes, yeah, he's right. And, so that became really important. Theory of evolution. Darwin, same thing. People didn't want to believe that we evolved from apes. The evidence is completely clear. Interesting, now we get into interesting ones. Health effects of smoking and secondhand smoke. Vigorously argued by the cigarette industry. Go figure, what a surprise. They were going to lose money because we figured out that cigarettes cause cancer. By the way, my mother died of lung cancer. She was a smoker for 30 years. Killed her. So, this is kind of meaningful to me. Interesting one, cold fusion. Major scientific controversy. What happened to cold fusion? If you remember, that was the idea that we could have fusion energy. Energy would be too cheap to meter. We could do it from, I think it was palladium metal. And it was this big discovery made by the University of Utah. But nobody could replicate it. It crashed. You don't hear about it anymore. Importantly, science is self-correcting. If somebody says this new idea, I can make energy so cheap we won't even have to put meters on our homes anymore, but you can't reproduce my experiment, then it's all over, right? The idea dies because science also has replication associated with it. Now we got human-caused climate change. Are you surprised that the oil industry is saying that's not right? Of course not. You know, they make money off of this. Of course they're going to say, oh, it's not real, climate denial, you know. It goes along with these. There's a great book, by the way, by Nomi Oreshti called Merchants of Doubt, which really traces this history of science denial through all of these things, if you're interested in that. Okay, now let's get to climate. Climate and weather. Really important to understand the difference. Weather, we had some great weather coming over. I love weather. I love when it gets cold and stormy, snow, sunshine, you name it. I love those changes. Change every day, you know. That's what weather is. Climate is different. Climate is the long-term conditions. Climate changes that occur over decades, a long time. Earth's climate is determined by the balance of energy flows on the planet. But wait a minute, we can't predict the weather in 2 weeks. How can we predict the climate in 10 years? Well, they're really, really different problems. So I can't predict the weather in 2 weeks, but I can tell you in 4 months it's going to be colder. In January. Or how many months? Maybe January is only October, November. Yeah, 4 months. Well, wait a minute. How come I can predict the weather in 4 months, but I can't predict it in 2 weeks? Well, that's because the Earth is shifting on its axis. The sun hits the Earth in different ways. We're changing the formula. We're changing the game. We're changing the balance of energy. So if you run into a climate denier and they say, but you can't predict the weather in 2 weeks, you say, okay, fine, I'll predict it in 6 months. I'll bet you $100 that it's colder next January than it is today, and see if they'll take the bet. And then you're like, well, that's not fair. Of course it's colder in winter. That's right. That's exactly the issue with climate change, because we're looking at the long-term balances of energy on the planet. I think this is the most technical slide I have. I have another one, a better version of this that's even more technical for the real geeks, but it helps to understand some real basics. That energy balance on the Earth is really just a couple of factors. Visible light comes in from the sun and hits the Earth. Well, the Earth heats up, just like a frying pan. I often think of this as the frying pan model. Earth heats up. It has to give off energy somehow, and it gives it off in the form of infrared radiation. That is the basic energy balance on the Earth. Now, greenhouse gases act as a blanket, and it reabsorbs that infrared. So the more greenhouse gases you have, the more that surface of the Earth will heat up. We have a natural greenhouse gas. It's called water vapor. And that turns out to be really important, because without that natural gas, the Earth would be about 30 degrees colder. It'd be below freezing all over the surface of the Earth. We wouldn't have life. So there's a natural greenhouse effect. Well, we're adding to the natural effect. We're adding carbon dioxide, which is also a greenhouse gas. These are concentrations of carbon dioxide. These are from the Mauna Loa Observatory, the longest record. It goes back longer than the 60s, by David Keelan, a really good scientist, started out in the 50s with NOAA. And then these are our measurements at Mount Bachelor, actually, published by Crystal. And you can pretty clearly see this every year, up and down, up and down, up and down, and increase. And it's increasing now about 2 parts per million per year. So you see those squiggles every year. Anyone guess why is it squiggle? Why does it go up and down there? So every year. I'm going to give you a hint.
Summer. In summer, like all of the trees photosynthesize and absorb all of the CO2.
Exactly. The Earth is breathing carbon dioxide. And it brings it in the summer and turns the carbon from the atmosphere into wood and trees, well, leaf. And then in the winter, it exhales it out, it decomposes, and you get that very regular all over the Earth. It's stronger in the northern hemisphere compared to the southern, because there's more vegetation in the northern hemisphere. Next job. We actually really understand that increase very well. We've done hundreds of studies that have looked at that increase. Isotope studies, mass balance studies, you name it, many different ways of modeling it. It's due to us. It's due to us burning fossil fuels, coal, oil, gas. And if you just took that heating effect and just think about it in terms of going back to this plot, it turns out that that is the equivalent of 2 watts per square meter over every square meter of the Earth. Now, you know what a watt is? I mean, I think of them as those little Christmas tree bulbs. Just those little lights like that, that's about a watt or 2 watts on every square meter of the Earth. Is that going to heat the planet? Well, yeah, it is. So, NASA, Goddard Institute Space Study, world leader in these temperature records, been compiling these for many decades. They've been around for at least 30 or 40 years. Most reliable source. We are getting warmer in the last 60 years. It's been about a 1 degree C. I was going to show trends in the Pacific Northwest. Turns out they were remarkably similar in the Pacific Northwest. The trend is almost exactly the same. You know, we can argue with that or not, I mean, whatever. It's getting warmer. I think you've heard 2018, 2017, I forgot which year, one of the warmest years on record ever. I mean, you know, the pattern is pretty similar. But a really, really important thing is when we talk about climate change, it's not just temperature. There's a whole bunch of changes that are happening. And I have to remember them here. We got the greenhouse gases. Hundreds of studies proven this is due to the fossil fuel combustion. We got the temperatures over the past 60 years. It turns out nighttime temperatures are increasing more than the daytime temperatures. And that has to do with the fact that the infrared radiation is lost predominantly at night. And that makes sense. We also have sea level rise. Well, where's that water coming from? Water in the ocean coming from 2 sources, coming from melting ice. And it's also coming from what's called thermal expansion, because the ocean warms. So glaciers globally, Arctic sea ice going away. It turns out there's a lot of biological changes happening as well. Animals are showing up in places where they didn't used to be. And they are all consistent with a warming world. And then, you know, if you look at 1 through 6, I don't even have to talk about computers there. Now at 7 I can talk about computers. Oh, we have these fancy, sophisticated models that run on supercomputers, and we can actually do very, very well at reproducing these trends. So, you know, again, if you ever get into a debate with someone, it's not just temperature. It's all of these pieces of evidence, and they all point in the same direction. Some grim pictures. We won't spend a lot of time on them. I haven't updated this one lately, but, you know, the Arctic sea ice situation has gotten much worse since 2012. I have a lot of pictures of glaciers in Washington. There's some historical photos going back 30 or 40 years. So here, I've actually climbed this peak, Forbidden Peak. I did not take this picture though, but I have climbed that peak. And here, this glacier filled in this whole valley. This is all rock now. So the only ice in here is just these 2 little bunches right there and there. I have many of these pictures. I think I have some extra ones if you want to see more of them, but the glaciers are going away. They're going away in Washington, in Greenland, in Europe, all over the world. Glacier National Park, in 30 years we'll have no glaciers. So, all right, who's doing it? Where do the carbon emissions come from? Well, for a long time the U.S. was #1 in the carbon emissions. On about 2005, China took over, and we were kind of flat, and we actually started to come down a little bit in the last few years. China is now the largest emitter. India is getting on the scene. European Union is coming down along with the U.S. Anyone guess why the U.S. is coming down now? It's definitely not due to Donald Trump, I'll say that.
Is it like population sort of, I guess, becoming more stable?
No, I think we're still growing a little bit.
Electric cars? Electric cars?
Yeah.
I don't know. I'm guessing that's a small contributor. It is a
No,
small
you-
contributor.
The US started outsourcing all the textile, everything to China, right? So all
Well, my answer, we could all debate this. My answer is we've been shutting down coal plants left and right. And we're switching to natural gas. And natural gas is a much more efficient in terms of carbon per unit of energy. Now, I just saw recently in the city of Seattle, we're trying to outlaw natural gas homes, or at least for new homes. So it's kind of an interesting, you know, Seattle really wants to be out there as the leader, but everyone will be back on electricity, which we can do for renewables. But I think if you look at the data, at least the way I've seen it, the natural gas conversion would be the largest factor. All these other ones would also be important. This is kind of interesting in terms of, you know, ethics, you think about how much each of us emit individually, as individuals. Well, the United States isn't quite number one, but we're almost. On a per person level of the big countries, we are by far the biggest emitter. Compare that with European countries, Japan, Germany, compare that with China. This is now, China's gone up a lot, but they're still half of what the United States, some other European countries, and India about 0.4 or so on this scale. Now when we come to the carbon footprint calculation, which we're going to do, I wanted to put this, there's different ways you can express this. I express it in terms of metric tons of carbon per person. You could also express it, gets geeky now, you could express it in metric tons of carbon dioxide per person. You could also express it as metric tons, or pounds per carbon dioxide. If you really wanted to be, old school and use pounds. Anybody in chemistry class taking chemistry lately? Where's our 15-year-olds? Yeah, okay. You should be the experts at converting pounds to kilograms to metric tons and carbon dioxide to the amount of carbon. What's the ratio between mass of carbon and the mass of carbon dioxide? You don't have the answer. I won't put you on the spot. What's the ratio of the mass of carbon to the mass of carbon dioxide? One's an atomic weight, one's a molecular weight.
1:4 almost, right? 1:4, isn't it?
Yeah, 12 to 44.
44,
Yeah,
So,
yeah. There you go. Anyway, I like to express it in metric tons per carbon per person because it turns out that if you do that, it's almost 1 metric ton carbon per person for the global average. Now it's a little higher. It used to be 1, and globally we're going up, and we're going up because of China. We're going up a little because of India with large populations, and they're starting to develop, even while the United States per person is coming down. So if you think about this, the United States population has not come down, but our emissions are coming down a little bit. So we used to be even higher on this, but we're still one of the highest in the world. Okay, let's get to what are the consequences, what can we do about it. Some additional climate change is inevitable no matter what we do. We are going to have to adapt to a warmer world. We do need to be thinking about that, but we need to reduce CO2 to avoid more serious issues. So that's what we have to think about. I'm going to skip that one. And then you can think about the impacts in the Northwest, in developed countries, but if you go to places like Bangladesh, they are really a tough place. Some of these poor countries, they're going to have a hard time protecting themselves. 150 million people, 80% live within a few meters of sea level, and so there's a real global equity issue. Honestly, if we have to if Seattle has to build a seawall to keep the sea out, we will. But I don't think they're going to build seawalls around Bangladesh. So there's real moral issues here. All right, what can you do? So here's my list of what you can do. And I want to say not everyone does everything. You do what you can. I have bad areas for me. I fly a lot, but I have my good areas. I bike and I have solar panels, Driving is probably the number one for most of us. Walk, bike, take public transportation. Fly less, eating less meat. Turns out agriculture is a big source of carbon emissions, and meat is the worst, by far. Factor 10 compared to plant-based diets. What do you think, burgers to dinner for dinner? No. I know it. But that is a big one. We were talking about the Impossible Burger on the way over. I was going to try it. I haven't tried it. I'm not a big meat eater, but plant trees. Go solar! I have solar panels in my house. They provide all of my electricity for my family. Family of 4 in Seattle, Washington, one of the rainiest places in the country. They work. I added this one because I'd forgotten about it. Buy less stuff. It turns out when you buy stuff, you're basically buying someone else's carbon emissions. And, the more stuff you have, that is more impact on the planet. And the last two, I think, the next to last one, vote for candidates who support the environment. That's pretty obvious these days, I think. But the last one maybe isn't. Supporting environmental groups. I belong to probably 6 or 7 environmental groups. After the last presidential election, I doubled or tripled my donations to all of them as a way of thinking, what could I do? Because they actually do really good work and really, really important work. I'm a firm believer. I see them suing in many times to maintain environmental conditions, and I think it's absolutely critical that they have the resources to be able to fight on behalf of us. So, going solar, my house, you can see there's one more set that's not in this picture. Just, this happened to be our first year. They had predicted we would get 5,500 kilowatt hours. We actually got 5,300. Obviously, we make most of our energy in the summer, very little in the winter, and we're selling it to Seattle City Light here, and we buy it back from here, and it's zero over the year. So that's a cool thing. Wind is now coming into play. We have lots of wind farms in Washington State. It's becoming one of our largest, after hydro, it is now our largest source of electricity. It's a great thing. If you ever drive out to the Columbia Gorge, you go out, you see these wind farms, windmills for miles. It's really great. There's a lot of positive signs. We have renewable energies becoming widespread and cheaper than fossil fuels. Wind and solar are now cheaper than coal. Many states in the U.S. and the countries have made strong commitments to reducing greenhouse gas emissions. All right, we have a trivia quiz. 1, 2, 3, 4, 5 questions. Can we do our trivia quiz? All right. There's the questions. Is coal coming back like Donald Trump says?
No.
Wind power is booming around the United States. What is the top state for wind power in the United States?
Texas.
Oh, you guys, you looked at my slides. Let's see. You won't get them all, though. The Kentucky Museum of Coal, not just in 2017, I think it was, switched its primary power to
Coal.
Solar,
Natural.
solar cells, solar panels. Pretty amazing. The Kentucky Museum of Coal. All right, according to the U.S. Bureau of Labor Statistics, fastest growing occupation in the U.S. I'll hold that one on. And here in Washington State, we have this massive number of wind farms in Washington. Was it a voluntary move by our regional, well, so the statement is it was a voluntary move by our regional power agencies, true or false?
Always true.
Coal coming back? Not a chance. They are closing coal mines left and right. It's a dying field. And we do need to think about what do we do with people who were coal miners in Kentucky and Ohio and all the places. I mean, we need to figure out ways to give them jobs. That's the criminal piece that Trump isn't doing. He isn't actually helping those people get jobs. He's saying, oh, we're bringing coal back. Coal's not coming back. That's ridiculous. We need to figure out how to get jobs to these people. Top state for wind power, Texas. Way, way, way in ahead of the rest of the country. They have a lot of wind, they have a lot of land. The utilities have actually figured out there's a really good business model because they pay farmers to put wind turbines on their land. Everybody's happy, it's win-win. Washington, I don't know what year this is, 2017. Yeah, we're pretty good, but nowhere like Texas. California's bigger. Even the Kentucky Coal Museum is going solar. I think that's so amazing. Fastest growing job in the United States? Wind turbine service technicians. And was the rise in wind power in Washington State voluntary or not? It was due to citizen initiative. 937, passed by citizens in the state of Washington in 2006, 52% approval. We made it happen. We made it happen. Our action made it happen. It requires the elect, not hydro. Second state in the nation to pass that, Colorado's first. 21 states now have renewable requirements. Highest percentage is in Maine. So Colorado and Washington led the country on to require, not voluntary. They had to do it. That was law passed by us, voted in by us. So it's a really good thing, right? I mean, hey, we can do something. Again, ending on cartoons. I always like this one. What if it's a big hoax and we create a better world for nothing? That's kind of the level of the argument some days. But thank you, and I'm happy to answer any questions. One one question you might think about, we'll come back to it, this number, the US average per person, 2.8. And before, I said the US average per person is about almost 5. What's the difference? Why are those numbers so different? What's not in here? There's a bunch of things not in here.
The industry
The amount
tax
of
that you have
Yep.
to pay.
Yep, and also going back to what you buy.
Yeah.
There should be a column here for how much clothes and stuff you buy, and, you know. There's another big thing that's not in here, is military. So every one of us, as a US taxpayer, that we're paying for the Army, the American Army, and, you know, they consume a lot of fossil fuels. Whose budget do they get charged to, essentially? I mean, you can think of things like that. So this is only covering these 5 items that we can directly control, I think, yeah. So, yeah, give it a shot. And I'll show you my numbers.
So
Yeah.
if we want to reverse the climate change, what should that number be?
We lower that.
Well, this number, probably 1.
1.
Have to get down to about 2 global, you know. I mean, we get into equity issues, like should the United States have to go all the way down to 2 so India can come up to 2? I mean, those are real arguments that have happened, that take place, you know, and so
No,
how
like
do
if
you...
everybody goes down by 10%, will it take us 10 years or 20 years to go back in the reversal effect, or is it going to take 2 years to go back? Has any analysis been done?
Oh yeah, lots of analysis has been done like that. And actually, one of my former one of my former graduate students, Dave Reedmiller, took a position at the U.S. Department of State. He actually went to the Paris negotiations, and he was actually one of the ones behind the curtain. He was not a negotiator because he was a scientist, but he was actually one of the scientists at the computer, and the negotiators would come back and go, hey, what happens if we agree to 5% here, but we go up 5% here? What will that do? And he'd be furiously typing on the computer to try to make answers to those kinds of questions.
So US pulled out of that agreement, right? Paris
It
agreement.
did, yes.
Yeah.
Yes, things have kind of gone downhill since.
But companies
November
are signing
2016.
up for the Paris Agreement on their own.
Yeah, and states,
States
that's
and-
right.
yeah.
There was a lot of negatives I could have said tonight, but I figured. Do you want to see mine?
Yeah.
Do you have them?
Yeah, it's
Yeah.
on the next.
So, just go to the bottom line first. I beat the US average, I'm below the US average, that's good.
What is it?
Mine's 2.26. But, if you scroll through the numbers, go up to the top now. Electricity, these are personal numbers. Electricity, 0. We have gas heat. So where's gas heat on here? There's my gas heat number. So that, you know, that was about the US average, because the 3 people in my house now. Okay, I don't drive very much. I drive some, but I don't drive very much. So So, gasoline consumption, I'm way below the US average, 200 gallons or something like that. I don't drive very much and have a pretty good car. This is my problem. This is what throws me over as I fly a lot. I'm one of the scientists and I like to go to meetings, and we go to meetings and we hobnob and a lot. And it's pretty amazing. That is more than half of my values on this.
Wow.
It's pretty amazing. If you added your trip to India,
Yes.
I mean, it's like,
That's
really,
almost like 1/3 of it.
yeah.
And I didn't fly apart from that anywhere, and that itself contributed to
Yeah.
a huge
Yeah.
portion of the.
So it's really interesting. Now, you may know Boeing is working, and Alaska Airlines are working on biodiesel fuel that can be grown and can be carbon neutral. We're not there yet, but it is something that needs to be important.
So when you travel that many miles, but you are not the only one who is traveling, there are a bunch of other people in the plane too,
Yeah.
does that help?
Yeah, well, no, that's taken into consideration in this calculation.
Okay.
That is my, you know, a plane uses a huge amount of jet fuel to go anywhere, is kind of what it says. And this is the contribution, this number, which if you take your miles flown times about each mile for each person, is about 1/2 pound of carbon dioxide.
So you know they do that Blue Angel every year, and you know why do they have to do that?
It's part of the military exercise.
Yeah, this is sort of going back to America being built on guns and war machines. You know, this is another interesting question and debate. Yeah. You know, I went to the Boeing Museum recently. I'd never been there. Actually, we had a smoke symposium there. It was a smoke symposium, the Washington State Academy of Sciences Smoke Symposium, and it was at the Boeing Museum. And I'd never been to the Boeing Museum, so I left the meeting and I went around the museum. It is pretty amazing how much planes and war are tied together. The history of planes, a lot of it, you know, we think about it as the history of the Wright brothers who built the first plane and flew, but after that it was really became a military weapon, and so it's really apparent in that museum how much planes were connected.
And I recently learned that the fuel efficiency for flights is in gallons per mile. Normally we calculate miles per gallon for cars. So it's that much amount of fuel to actually lift off the plane and keep flying.
Are you able to show where you calculated from here to number of saplings?
Sure.
So while she's getting that, there are a lot of carbon calculators. You can go online and you can do this. This is one that I've used in my own class. I like mine because it's easier for me. Some of the ones because you can really look at all. But there's many of these kinds of calculators. They all give similar results. Some of them have more detail, less detail. But,
So this uses metric tons of CO2.
yeah, and then in the last, it's metric tons of carbon. So each level you can see the conversion. And the difference between this one and this one is 12 over 44. You're going to tell me how many trees I need to plant. The thing about trees, so I wasn't quite sure I understood. What I understood is when you plant a tree, while it's growing is really the best time when it's putting on carbon. It's putting on weight and taking that carbon from the atmosphere. So.
What's the metric ton of CO2? Yeah, so it's 137 seedlings grown for 10 years. As I said, I think that's when it absorbs a lot.
Yep.
And it's equivalent to 9.7 acres of US forest in 1 year.
So this is for the U.S. forest. They're not as, if you look at it per tree, they're not putting on as much carbon as a seedling. The seedling's putting on more. I think.
More,
Yeah.
yeah. And if it's a preserved forest, then you just need 0.067 acres of forest.
Conversion.
For
You're
to
protecting
sequester
it.
that.
Yeah. That's like the forest, the land in Redmond, like that's out here, that's being converted from, oh, no, it's the other way, from forest to farmland, yeah. I'm thinking from farmland to houses. I mean, tricky problem. Okay, what's the one thing you can do this year to make a difference in your carbon footprint? Don't ask me to fly less. I'll bicycle more. All right, I'll fly a little less. Anybody want to share their idea?
I'll ask my wife to buy less stuff.
Good luck with that.
Buying more stuff from Amazon.com, so don't have to drive to buy.
Somebody
No, we
else
can
will
do
drive
an
it.
analysis on that one, you know. Especially if it delivers it by drone, you know, then.
Turn off the light when you leave the room.
Turn off the lights, switching to LED lights if you haven't already, I mean, you know.
Convince people to go vegan. I know it's hard, but that.
Yeah, it's actually a very big effect.
Yeah, there are big industries now, they're making a vegan stuff, right?
Yeah, yeah. And I mean, it'd be interesting, I don't know if any of the carbon calculators online have questions about your diet, because those are important in terms of your carbon footprint. I didn't put them on there because I didn't know how to put them in, but they're not so easy to quantify, but it is definitely true.
I think telecommute is also one option.
Cool. Yeah.
So more than so what I think is whether all the, so now we had an opportunity to get educated on this from Dan. Like this, we need to have more awareness with the people, right? So it's not one person, yes, we need to contribute, like the Jan did his contribution, zero power buying. So then like we follow and then spread the word across and involve more people, because it's not limited to few people, it's the whole universe, it's the whole earth. So when we start spreading this word and everyone will, okay, should I buy this? Should I buy this? Maybe then there are a set of people who will come, okay, if no one buys the cloth, then what happens to the industries? People will go hunger and all those things. We don't need to worry about that. Spread across the world what is the impact. Everywhere, wherever is possible, do not print, follow the rules. That's what I think. Spread the message.
Yeah, I think these are all good things that we can take back and do in our own lives. I had a couple of questions from folks who when they signed up, they had asked some questions. So one question is, what inspired you? Any particular event that inspired you?
Working with students, is really great. They have wild and crazy ideas, and just being able to make an impact. Yeah. I like talking to groups, so that's fine and fun. Yeah.
And I think many of us have this question. It's so cloudy here. So how efficient are solar panels in Seattle?
Well, okay, so we go back to that. Well, I don't need my slides. My system here that I showed you in my house makes all the electricity. Well, now there's 4 of us at home. Well, now there's 3 of us at home. My daughter's moved out. But made all the electricity for the 4 of us. Not uniformly through the year. More in summer than in winter. We sell it to City Light and we buy it back and it's 0. The same solar panels in Arizona would make about 3 times more.
I see.
But I live in Seattle, what do you do? But still, it works. It totally works.
What does it take to set it up, and how much does it cost?
Yeah, that system cost about $20,000. And based on the price of the electricity, and the state of Washington has a subsidy program, it'll be paid off in 7 years. It's almost paid off in terms of just saving electricity.
I see.
And then it's free electricity for the next 20 years. So it is a very big cost benefit in doing this.
Is the rebate program still going on, or
It's declining. So I don't know.
They're not encouraging more people.
Yeah, I don't think the state is encouraging more people.
But the solar must be getting cheaper.
It
as
is
well.
getting cheaper,
Yeah, so
exactly.
it goes
Yep.
hand in hand.
So
So why is the state not encouraging?
why is,
The state not encouraging?
well, they put a set aside of money for this program and they didn't put any more. I mean, you can call your state rep and say, hey, put more money in. But I think the idea was to get early adopters. Sort of the same argument for electric cars. They'll have a subsidy for the first 500,000, but once it's widely adopted and people see the value, then the subsidy's going to go away. Yeah.
It probably as more people adopt the solar power, so per capita subsidy also comes
Yeah,
down.
actually that's exactly right. The subsidy, the first couple of years, they set a dollar limit on it, and after 3 years they'd hit the dollar maximum. They said, oh, sorry, your subsidy's going down this year because we had too many people in the program. Okay, so too much success.
Right.
Yeah.
So you just search for the companies who can set it up and they'll come and do it.
Yep. Yep. I have a presentation. It's really interesting when they come. First of all, you have to have, your house has to be well situated.
I see.
You can't, if your neighbor has a big giant tree right there, it's not going to work. And so there's a little bit of luck to it, how your house is situated. And what's kind of fun is when they first come out, they put a device like a radiometer, like we had up at Mount Bachelor, and it's actually looking at the sun and how much of your sun, where the sun would go in the sky, and how much of that path is open versus blocked. So the first thing you have to figure out is how much sky your roof is going to be able to see. And then you get these cool pictures of where the sun is going and different times of year. Yeah. And then depending on how many panels you want to put in, then they'll estimate what your electricity production is going to be and give you an estimate of the cost. So.
And for people living in apartments, is there an option, like a way to choose renewable energy? I know you can't put solar panels on your roof.
Yeah, there are some buy-in programs where you can put money into a pool. There's actually ways, the carbon offsets, where you can put money into a pool that pays for solar electricity generation somewhere else, and you're actually you're buying that electricity in.
I see.
Yeah.
Okay. I'll look into those.
Yeah.
That sounds interesting. Thank you. So I know we have to buy less stuff. So if someone's thinking of moving from their current combustion engine car to an electric car, what's the trade-offs when you're trying to make that switch?
Well, miles per gallon, obviously. I mean, we own a Prius, and I mean, probably a lot of you have Priuses. It gets 40-something miles to the gallon. But it's not very good for driving in the mountains in Washington. It's really low. We like to go hiking, so we'll get in the Prius, and then we get out on the mountain road, and it's really rough, and we're whacking the bottom of the car. So, you know, those are the kinds of trade-offs that you have to think about for yourself. But whatever level of car you decide you need, you know, buying the most energy-efficient model you can is the key.
And try to carpool and
Yep.
all the other things.
Yep.
To
Yep. Yeah. What I usually do, my bicycle ride, my commute to work is about 12 miles. And almost every day I bike one way and I take the bus the other way. Because if I'm teaching, I like to just get to work and not be sweaty and take the bus in and then I'll. So thinking about where you live is very important, actually, because I really thought a lot about where we wanted to live so that I could have a good commute. If I had to drive on 4 or 5 every day, you know, I'd go crazy. So,
yeah, and the
thinking about where you
calculator really helped in seeing that how much of it is actually coming from electricity versus the car usage.
Yep.
And my car usage was way more than all the other electricity, so
Yep.
definitely a point to be
Yep.
And I think you mentioned offsetting carbon. Do you suggest any offsetting programs that you're aware of?
I'm not going to suggest a specific one, but most airlines now are offering that. And what they're doing, you have to make sure it's reputable. When carbon offsetting first started, there were reputable ones and not reputable ones. But I think now there's more controls on them, and I think most of them are reputable. So, you know, you see that you can, in fact, offset your carbon. So I think it's a good thing to do for these trips. Now, I don't know if we should count that as in the calculator. Do I get to buy out of my air mile carbon dioxide? No, not really, but it is still a good thing to do environmentally. Yep.
And coming to that, it's said that if you plant 1 trillion trees, we can completely reverse climate change.
Okay.
So what's your take on that?
I think we need everything. I think there's no one silver bullet. I think we're going to need every possible strategy. We're going to need more efficient homes. We're going to need more efficient cars. We're going to need a lot more renewables and more efficient renewables. Right now, my solar panels only using about 10% of the sun's energy. Throwing away 90% of the sun's energy. Wow. I mean, if clever minds could figure out how to double that, it would be huge. You know. So, but we're going to need all of those. I don't think, you know, right now we're seeing, when we say, you know, if we just replanted trees, you get into political issues like in the Amazon in Brazil. We've seen there's been these huge fires in the Amazon. Why? Well, because farmers are trying to make a living and raise more crops and probably grow more cattle, and they're trying to make a living. It's very, very hard for us in the United States to tell them, no, you can't do that. Now, a lot of that was illegal burning. The government of Brazil kind of said, well, we don't really think that they should do it, but they weren't doing anything about it. So it's very tricky. You really need every possible strategy. I don't think it's going to be just we're going to plant a lot of trees.
I think we've already collected enough carbon dioxide that even if we stop producing carbon right now, we have to actually go back and reverse all the carbon dioxide.
Yeah. Have you ever heard one? Sometime you'll go out to, you know, Pasconomy Pass. They're about 80 miles from Seattle. There's actually a tour of Seattle's, I think it's Puget Sound Energy actually has the tour. It's a really good tour. I haven't been there, but I have been up close to them. And they do make this whoosh, whoosh, whoosh sound. I think the biggest impact on animals is birds who hit the rotor. And it is a big impact. So they have to think very carefully about where they put them. And they're starting to think more about how do they design so they're not traveling as fast, but it turns out when they're going faster, they kill more birds. So it is an impact. Yeah. But, I mean, just to take a devil advocate, we could also argue what's the impact from a coal plant or a natural gas fired plant and say, well, what's that impact, and try to compare these two. Yeah, because nothing's without impact.
So I read this article about refreezing the Arctic. Have you heard about that? And like, what do you think? And is it possible to do it sustainably as well?
I've not heard of that.
Okay.
It would take a lot of cold.
Mm-hmm.
And you know, the irony is to make cold, you have to make a lot of heat.
Right.
It uses electricity. Is there some clever way to do that? I don't think it's going to happen anytime soon. It's a very, very difficult problem because we're talking about a large land area, or a large ocean area, and very remote. So I don't see it happening. I'm a little skeptical on that one.
One question, like we say going electric is to, it kind of says all these things, but production of batteries itself is kind of can cause this whole carbon offset, right?
Yep.
How does that impact on the disposal and all?
Well, the biggest issue there is the toxics, I think. And you know that when our electronics, when we're done with our electronics, a lot of them in the United States, a lot of them end up in third world countries in Asia, you know. And I think the biggest issue, I don't know so much about the carbon issue, but the toxic issue is as big as cadmium, usually in batteries and lead and different metals. So I mean, other than that, I don't really have an answer. So yeah, I mean, I think, you know, I'll say when I go somewhere and I bring my laptop is now going on 7 years, and I could tomorrow. I have plenty of money, you know, or I could buy it through my work and I can get a new laptop. But I'm really trying. It's still working. It's actually working just as well. My office computer is a year old. My home laptop is 8 years old, and it's actually working. It's got a few streaks on the screen and all that, but just going back to making things last longer and avoiding throwing things out is the impact. So, you know, going from a situation where you're buying a new laptop, you know, for me, every 8 years, I don't know if that'll last. It could die tomorrow. To one where I'm buying one every other year is a huge impact. It's a huge impact.
So from what I understand, governments, they subsidize non-renewables more because they're more economically viable, because I think they have a higher net energy yield. So why don't renewables such as solar energy and wind, why don't they have as high of a net energy yield, and why aren't they as economically viable as non-renewables?
Well, I think the subsidies, you're right, fossil fuels do get larger subsidies than renewables. It's really a historical artifact. And, you know, oil producers in Texas said, hey, we can't produce oil. You need oil, look at America's growing, we need cars, and we need a subsidy, sort of like the subsidy on my solar panels, right? Okay, so we need a subsidy to produce this oil, so help us produce this oil, and for every barrel we produce, da 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 da. And I think it's really just a historical fact. When you say energy density or yield, it's a little bit hard to compare. Like, how do we compare the energy yield from, you know, oil, which we can burn? We can burn oil with 80% efficiency, to my solar panel, which I can only get 10% of the sun's energy. But wait a minute, we're talking totally different things. We're talking about oil, which is down in the ground, which is non-renewable, is never coming back. You drill that oil and, you know, it's never coming back. Whereas my solar panels, I'm getting those, you know, sun's still coming. So should we compare the 80% efficiency for burning oil with the 10% efficiency for solar? That doesn't make any sense. So I think those fossil fuels, you're absolutely right, those fossil fuel subsidies are there and they skew the system. But now we're at a point where wind and solar on a commercial scale are significantly cheaper than coal. And that's a big reason, well, really that and natural gas is part of the reason why the US emissions are coming down. Those coal plants are closing all over the place. There hasn't been a new coal plant built in years, and there isn't one being built under Donald Trump's watch. Here's Mr. Coal himself as president. He can't even get coal back, and mines are closing around the country. Now, you may know that in Washington, there was a proposal for Wyoming to send coal to Washington State and to ship it to Asia. And that was going to be, it wasn't one proposal, there were like 4 different ports up and down Washington and Oregon. 3 in Washington, 2 in Oregon, different companies. And so Wyoming and Montana wanted to ship coal from the Powder River Basin through Washington and Oregon and then put it on barges and ship it. And Washington State and Oregon fought it. And I'm happy to say we won. And we actually did some research on that because we helped a little bit in terms of looking at some of the environmental impacts. So that's actually an area where I feel like I was able to make a little bit of a contribution in providing some of the data showing the environmental impacts. But, they can't sell their coal anymore in the United States. I mean, coal is going down. It's still used. I don't want to say it's gone. It's still used a lot, but it is going down. And it's partly because it's cheaper to have renewables and cheaper to have natural gas. So that's a great success story in terms of carbon footprint.
One last question. Yes.
Go ahead. I have kind of 2 questions. One is for my guidance, but another is question. I saw you have done a lot of research in air pollutants, and recently there has been a lot of wildfire. Have you seen how the smoke from wildfire is impacting the air quality around the near area and also in the area that are far? And another is, I will be studying the wildfire using the remote sensing data. And are there any unanswered questions or the areas that I could focus on other answer?
Well, if you come to the thing Tuesday night, downtown Town Hall, Seattle, you can learn all sorts of stuff about wildfires, including what we're doing. There's tons of activity going on with remote sensing and satellite data. Lot of very interesting questions. If you talk to me afterwards, you're doing science?
Yeah, I'm a PhD, starting my PhD at UW.
Ah, okay. In which department?
Environment and Forest Science.
Ah, okay. You should come and talk to us or give a seminar out to our group or something like that. Satellites have fascinating and very valuable information on smoke and fires. We don't fully understand how to use it all. And I have pictures, if you have a minute I can show you. You can look at a fire and you can see part of the fire is white and part of the fire is black because they're burning differently. And if a satellite could be able to look down and see which part of the fire is white and which part of it is black, that would be hugely helpful. It turns out that's actually much harder to do. It's easier with our eye because we're just there, but for a satellite to do it would be great. So there's many, many different ways that we need more better satellite information. So keep going.
Okay.
And we've studied smoke a lot. We have a lot of smoke, the chemistry of smoke, the hydrocarbons, the ozone, the PM, the NOx. You go to our website, we have bunches of papers on that stuff. Now we've gotten interested in indoor, how the smoke gets from outside to indoors.
Thank you so much for answering all our questions.
Thank you.
Thank you.
Thank you.
Good stuff.